Hello, my name is David Betteridge, and tonight we're going to have a go at solving a newspaper logic puzzle by writing a program in C#. I'm not going to pronounce its name, but you can see it here because I'll probably get it wrong. So the puzzle is reasonably straightforward. You get given a grid which is 5 by 5, and you have to populate each row and each column with the numbers 1 to 5. So 1, 2, 5, 4, 3 for example. And you've got an additional constraint, which is these greater than and less than symbols. So this says here that this cell 2 has to be greater than the cell immediately to its right. So in this case we know there'll be a 1 in there. And this cell here has to be greater than 2, so that's going to be a 3, 4 or a 5. To get us started, I've created a new console application and in C#, and let's get going. So the first thing we need to think about is the data structure which we're going to represent on the board. It looks like it's going to be an array of 5 by 5, and it's going to be an array of cells of some description, because a cell at a minimum is going to have a value and some way of representing these additional constraints. So let's start off with that. So I'm just going to use a two-dimensional array of, so I'm going to do a class of cells, I think. That's our array. And what else do we know? So a cell. So the way we can solve most of these puzzles is you work out all the possible values each cell can be. So every cell can at the beginning can have the values 1 to 5. And then what we need to do is eliminate those possible values until we get down to one of two things. Either there's one possible value remaining, or there's only one possible value which contains a number in a row. So once we've done both of those, we can start to solve them. So our cell is going to need to have a list of its possible values. So let's add that in. And so it's going to be numbers, so we'll use an integer for these possible values. So initially, every cell is going to have 1 to 5 as its possible values. So let's start that now. So let's initialize everything in the board. So we'll do column. So we'll just hard code the board size for the moment. We can always make this more generic and reusable later on. And then board dot. Right. So at the moment we've got an array of null values. So we say board column is a new cell. And each cell is going to have a list of possible values of 1 to 5. So we do enumerable dot range, starting at 1 or 5 numbers, and turn that into a list. So we start off with every cell having numbers 1 to 5. That's good. So now we know one of the cells. We know that cell 0, 1 contains a 2. So we can modify that. So it's column 0 because we start counting from 0. It's row 1, and the only possible value it can have is a 2. Right. So the first thing we know is so we know a cell's solved when its possible values only contain a single entry, so that's fine. And we know if the possible values, if there are any possible values for a cell, we know we've got a problem. So what we can do now is we can say, well, we can look at each cell and we can look at each possible value in the cell and work out whether it's still valid. And obviously here is not valid to put a 2, and it's not valid to put a 2 here or here. So we can check the columns and the rows. So what we're trying to do is for each cell, for each possible value, check it against some constraints. So this first column has this constraint that the number can only appear once in this column. So maybe, I've never tried this before, but maybe we need to have an interface called iConstraint. And our cell has a list of these constraints. We'll worry about setting them up in a moment. And then what we do is we loop over every cell, and if that cell has got more than one possible value, then we're going to try and eliminate any of these additional values. So we, there's almost a mistake there. So we need to loop through each of these possible values as well. And then we can evaluate our constraints to see if any of our constraints fail. This isn't it. Okay, yeah, we might run into a problem in a minute because we're going to be modifying this one whilst inside the for each loop, but we'll worry about that in a minute. So, I think we want to say if so if any of the constraints so if the constraint fails, oh, that, yeah, value not good. One, two, one. So what we're going to do is we're going to look at each cell in turn, which is what this outer loop does, and then for each of these cells we're going to see how many possible values we've got. And if we've got more than one, well, if we've got one exactly one, we know it's solved. If we've got more than one, then we're going to look at all the possible values and we're going to apply any constraints we have for that cell to see if there's a reason why that value is not valid. And if it's not valid, we're then going to remove it from the list of possible values. So we need to add this to our interface. And then we need to actually implement one to do with columns to begin with. So because a number can only appear in a column once, so that column constraint. So when we create this column constraint, we need to know which column it is we're interested in. And I think when we validate it, we probably should pass the board in as well. Save the property. So then when we're initializing the board, for each cell is going to have one of these. Yeah, so for each cell we're going to create a column constraint with its column number, and then to check it, we know that this value is not valid if there's another cell in this column which only contains a single possible value, and that possible value is this one. Actually, we can do this really easily. Actually, we can just say for row there's 1 to 5. We need to know our row number as well. I'm going to swap those around to be consistent with elsewhere. I normally put column number first. Okay, so now we know which cell we're looking at. So we'll look at each row, and if the row is not our cell, so it's not that one, then our possible values is column number, row, not possible values, and then if possible values dot count is exact, so we've got exactly one possible value, and that possible value is the one we're being asked to check, then we can return false, because we know that there's no way that this value can be in this cell. Otherwise we return true. Okay, so this could be quite tricky to debug, but we shall see. We might need to add some routines that just print out the possible values in each cell. So what we'd hope is we've eliminated some of the values from that first column. Okay, this is what I was worried about. Because we're looping around and we're trying to remove values from it at the same time, that's not going to work. So what we could do is we'll take a copy of it. Right. So. Okay, we've got that back to front because it's removed everything but our possible value. Yes, our function's back to front. The value is not valid if it breaks the constraint, so it's that way around. Okay, that's correct. And then the root one down here should tell 5 values. That's fine. So now we can do the same thing with rows. So exactly the same idea. So and we just need to add that constraint as well. So now we'd expect some, if we look at our diagram again, we'd expect some values to be removed from the second row. So row 1. So row 1's here. Yes, that's removed. I haven't moved it from one column. Right, sorry, that's a column. Yes, it's one's only in a 1. Okay, that's working. That's good. So we've already applied 2 sets of constraints. So the next one is to start applying these greater than or less than symbols. So we need to tell it whether it's less than or greater than, and also what direction. So we say this cell has to be greater than that one, and this cell has to be less than that one. So for each of these are actually 2 different constraints. So we add the constraint to that cell, we tell it the type of constraint and the location of the one to check against. Okay. So let's do less than. So row and column is let's call that this column, and this row, and we also have int other column and int other row. So I'm just going to add them as properties again and set them up. Oh, hang on. So this time, so this column has got to be less than the other column. So if it's less than the other column, so in this case this can only be less than that. So this has got to be less than the largest possible value in that column. So if this column can be 3 and 4, this column has to be less than 4. So first of all we can find the largest value. So that would be the largest value in the other column and other row. Maximum possible values max, and then the value is not valid if So this has got to be less than, so it's not valid if this value is greater than. And then we can do the same thing with the greater than extent constraint. And the only difference is we now find the smallest value and it's not valid if this value is less than that smallest value. Right, okay, so now we can add these constraints in here, but we have to do it on a cell by cell basis. So, 0, 0 is greater than 1, 0. So greater than. And we have to then do the opposite way around as well. So 1, 0 is then less than 0, 0. So we'll always add these in pairs, and so what we can do is create a function for that. And we pass in the int column greater than, int row greater than, and then we do the same thing with less than. Right, and we need to set those, so we're saying the greater than's on the left hand side and the less than's on the right hand side. This is so okay, so let's add in, let's add in the next three of them. So that's 4, 0 is greater than 4, 0 is greater than 4, 1, and 0, 0 is greater than 0, 1. And 0, 1 is greater than 1, 1. So if we run that now, even without the other constraints in, we should start to see this getting restricted. So 1 won't be available in there anymore because 1's not greater than 2, and 1 should be the only value in 1, 1. We didn't crash. So, oh yeah, so that's worked. Let's move that, and if we look for 1,1 possible values, 1. Yeah, that's correct. That's good. Okay, so I'm just going to drag that onto my other monitor so I can quickly add the extra constraints in. So okay, so now what I think we need to do is print out the board and see where we've got to so far. So we'll create a function here called display board. So we're going to display it row by row. So if there's more than one possible value, we're just going to write out a space because we don't know what it is. Else we will write out what that one value is because that's the solution for that cell. And when we get to the end of the last column in that row, we're going to write out a carriage return and put your space at the bottom. Okay. One would be clear with like an underscore or something for the ones we haven't solved. Okay, that's not wrong, that's probably correct. Okay. So the case we haven't handled is when there is only one possible place a value can go in a row. So we need to add some code for that. But also what we need to do is also keep looping, because now we've solved some things, we should find it affects other things as well. Looking at how we'd solve this manually. How would we solve this manually? So here, this is obviously quite constrained already. So if that was a 1, that would be a 2, 3. Oops. But that can't be a 2. So already that cell's already constrained down to 3, 4, and 5, because it can't be a 1 and a 2. And that's 3, 4, 5. But yeah, so what we need to do is just keep applying this loop to see if that makes any difference, I think. Normally we'd keep applying it until we solve the board. Just read key there. Okay, so we are going to do some more work, so this isn't enough. Right. I don't know if we'll have the case where there is only one available number in a row or column. Let's try that though. So what we're saying is for each row obviously has to contain the numbers 1 to 5. So if a row doesn't contain the number 1 yet, but only one cell contains a 1 in its list of possible values, then we know that cell must contain that value. So let's do it column by column to start with. And then within the column, we go value by value. So we want to how do I do this? So because it's a 2D array, we can't just use like a link where statement, because we want to work on a slice of it, in effect, either a column or a row. So column in this case. Let's write it the long-winded way, and then we can always refactor it into something a bit more elegant. So we're going to look at each cell in our column. We could... Okay, we'll start with long-winded then. So cells containing value. Yeah, this is going to be horribly inefficient, but we'll do it for a second. So if it contains a possible value, then we add it to our list of values. Oops. And the thing we're adding is the row number. And then once we get to the end of looking at all the rows in our column, we say if there's only one place that this value can go, then that cell must contain it. So what? And we can probably have a slight improvement here, because we can say we only want to do that if that cell hasn't already been solved. Okay, slightly more efficient, but obviously not very at the moment. And then we can do the same thing, looking at row by row. see if either of those fire. Nope. Okay, so we're going to need to do something else cleverer still. What numbers can this be? This is an interesting point. So, the smallest this number can be is a 3. Because it's got to be bigger than these two. So the smallest these can be is 1 and 2. So this cell can only be a 3, 4, 5. But we know it can't be a 5 because of that one. So we expect this cell to be either a 3 or a 4. So this is 0, 1, 2, 3, 3, 2. So let's see what value we've got in 3, 2. So cell 3,2 can be spindle format, our cell, column, comma, array, possible values. No, not string format, string join, and separator. We want to separate the commas. Okay, so let's see what we end up with here. Okay, we've obviously got something a bit wrong. First of all, if I can miscounted the cells. So 3, 2, 0, 1, 2, 3, 0, 1, 2. So it's definitely that cell. And do we not have any constraints? Okay, so 3, 2 is greater than 2, 2. That's correct. Oh dear. Had to take a slight break there because I had to sort some work out. So I'm back on to looking at this problem. So what we were is, got a problem here that these constraints don't seem to be applied. So there's no way we can have possible values 1 to 5 in this field. So I think we need to just debug what's going on when we apply those constraints. So we can just take that bit of code and we'll apply it just for one cell. So it's column 3, row 2. breakpoint there, and let's see what happens. What? Didn't expect that. Let's try that again. Is it null or something? Just killed Visual Studio. So that's not null. Okay. The first possible value to check is 1. Can 1 go here? So no, 1 shouldn't be able to go here because 2 shouldn't be able to go there. Unless we've got our logic back to front. So this has got to be greater than, well, okay, it's got to be greater than the smallest value here. So it can't be less than the biggest value here. No, it can't be less than the smallest value here. Is that our problem? Are we not quite restrictive enough? So let's just start from here. So this starts off with the numbers 1 to 5. Here, it's got to be greater than the smallest number. So that has to be greater than 1. So that has to be 2 to 5. Likewise that. So if this still had the numbers 1 to 5 in it, which it will have the first time through, it can't be a 2 still because it has to be greater than the smallest number. So the greater than constraint, so we find the smallest number and the value isn't valid. Yeah, that's the one. It's got to be greater than or equal to. Okay, that's better because that's down to, so second time through it's down to 3 and 4, which is what we worked out to be. Is that good enough yet? Doesn't look like it. Okay, so that's down to 3 and 4, so that's 4 and 5. Simply that's 2 and 3, 1 and 2. This. Okay, so we've worked out that is 3 or 4. So that must be 4 or 5. That's got to be less than that, so that's got to be 1 or 2. that can be 3, 4, 5. This one, 1, 2, it's got to be greater than 1, so that's 2, 3, 4, 5. That's got to be, well, that could be 1, that could be 2 or 3, that could be 1 or 2. Yeah, so that's 2, 3, 4, that's 3, 4 or 5, yeah, that can't be 5 of course, so that's going to be 4 or 5, so that's 4, no that's 5, that could be 4, that could be 3, that could be 2. This is bigger than what this is, so that could just be 1, 2 or 3. And then over here, that's 3, 4, 5. This can be anything. Well, 1, 2, 3, 4. That's a 1. We've already solved that one. Actually, that can't be a 1. So this it can only be a 3 and a 4. So that must be a 4 and a 5. Ah, that's how you solve it, isn't it? So, because this is a 4 and a 5, and this is a 4 and a 5, this can't possibly be a 4, so that's a 3. Because if that's a 4, that's a 5. And if that's a 5, that's a 4. So there's no way that can ever be a 4. So that becomes a 3. Doesn't actually help much. Becomes a 4, 5. Doesn't help much at all, does it? So now we need to think about how we're going to eliminate pairs. Right, let's think about how we can handle these pairs then. So, not 1, 2, so it's 4, 0. Or along 0 down. So we'll just print out those just to make sure our theory is correct. I think I might have just pressed undo and undo that. Okay, that's better. So that's 4, 5, 3, 4, 4, 5. So we know that that can't be 3, 4. 4 can't be there. So this, so what we're going to do, I think we'll just do some sort of brute force approach where we just, again, we'll look at each column, each row. If we find a pair in that row, we then check to see if there's any other identical pairs in the row, which is a bit horrible. And then if there is, we then eliminate anything that's in that pair from the other possibilities in that row or column. So it's going to be a bit nasty, but I think that's going to work. I wonder if we can do it as a constraint. It would be better. So the constraint is But that value is not possible if it's in exactly 2 pairs. So that's quite good, because then we could actually do it within the column constraint as well. Are there 2 pairs in this column which contain this value? So what we could do because fortunately all the values are already in numeric order. So what do I want to call it? I'm going to use the term possible values again. Okay, yeah, so all possible values. So we're going to have a list of strings this time. And we add to the list string join separator as values are possible values. So we track all the possible values we find. But we only want to do, we only need to do that if it contains the one we're looking for. Okay, so if there's a cell in this column which contains the value we're looking for, then we add all the possible values that cell can take into this list. And then when we get to the end, so now this is going to have between 0 and 4 entries, and if any 2 are equal and of length 2, we could actually also check the length, couldn't we? Here. If this cell has 2 possible values and one of them is our possible value, then we put in that list. And then if there is if we group them, we would do it all distinct. If the number of distinct entries isn't the same as the number of entries, that means we've got a duplicate. And if we've got a duplicate, then it can't be valid, so we can return true. That seems a bit complicated and very hacky. But it did work. Okay, so that's solving the free for us. So we can now do something similar for our rows. don't think that's going to help. Ooh. Oh, we've actually solved it. That's nice. Some quick look. So 3 is greater than 2, 3 is greater than 2, that's good. 4 is greater than 3, 5 is greater than 4, which is greater than 2, which is less than 4, 3 is greater than 2, 4 is greater than 3, 5 is greater than 4, 4 is greater than 3, 3 is greater than 1, and 3 is greater than 2. Yes, we've actually got some working code. So just spend a couple of seconds just tidying that up. The only thing so the only thing it might be worth adding is somewhere telling whether the board's complete. So, while not complete, probably should have written this first, and not complete. So it's not. I've done it. This first, reverse that. Let's call it while complete, and not it. So it's complete if all these cells have exactly one possible value. Which is going to be fairly straightforward. If there's a cell with a number of possible values greater than 1, we return false. Okay, and that's solved our puzzle. Hopefully you found that interesting. It took me a while, and yeah, made quite a few mistakes along the way, but got there in the end.